Now I made these circuit boards specifically for these modules. The first thing is we've got this little connector here. What do you call this? It's an automotive type thing. Goes through this hole. And that's in a spot to line up with this mounting hole here. Push that into there and it sits like so. There's a little screw that goes into that once we get round to it. Up the top, so that's the one, and then there wasn't anything up the top, so what I've done is I've put these two holes here. So these spaces fit nicely, they're the right spacing to make it like so. I will just take off this sticker and clean it up with some isopropyl alcohol first. Now sometimes this mounting thing has been broken off, and so at the bottom of the board I've got the hole for that one. Where's my next one? I've got the hole for that, but I've also got another hole there which suits the spaces. And so when you don't have that one, I'd put one of these on instead. It's not quite as strong, and it wobbles a little bit, but it's good enough. Next thing to do is to plug in these circuit boards. I'll just do this one to start with. Just do them one at a time. I'm just testing the voltage of each of these 6 circuits just to make sure it looks sensible. So it's about 4 volts. If there's a wire wrong or something, then you'll get weird things like you might be double the voltage for a circuit, which often results in the circuit blowing up, but anyway. So each of these so far is looking very good. This is the last one. Okay, they're all good. Now the next thing to do is to program the microcontrollers. So one of these chips here is the microcontroller. There are 6 circuits, so there are 6 microcontrollers to program. Do that with this little programming device here. The holes on the right hand side of this circuit board are just for programming. Press that button. When it goes green, it's done. So that going green is indicating that pretty much the entire circuit is okay, all your voltages are right, all the connections are fine, the microcontroller is working correctly and is accepting a program. These circuit boards, by the way, I designed them on my computer and then I sent away the designs to a company that created them. They made the circuit boards and populated all of the surface mount components. I've just soldered on a couple of through-hole components, the connectors. And so what that meant is that at this stage the microcontrollers were unprogrammed. So I've just programmed them and they should be ready to go now. So the next thing to do is I will calibrate the voltage for these. So I measured the voltage a minute ago just to see what it was. But it may not have been accurate because I don't know what the microcontrollers were doing and they may have been using power. When I'm actually doing this, I will use my more highly calibrated multimeter, but this one is good for giving an indication. So that voltage there is probably a little bit higher than what it was before. So the microcontrollers that I've just programmed, I now know are not using much power. So this voltage is what I want to calibrate to. So 3.98 is that one. So we're going to calibrate it to 2 decimal places, but we can read to 3. So 3.98 is for the first one. 3.97. So that's unusual. They're normally all exactly the same. And I do wonder if it is this multimeter. I will test it again on my other one later. Next thing to do is to plug this into the master unit and see if it's actually communicating. In theory, these should all be communicating now, so we need to plug it in and see. Here's a prototype board I've got for master units. It looks lovely, doesn't it? It's turned on here. It's not connected to anything. So let's plug in. We've got output here from that one is this here. So the output from the master goes into the input of the first module circuit board, and then they all talk to each other and it comes out finally here, and this one goes back to the input of here. You heard a click. That's because it's the master here has figured something out. So it is now showing the voltage of each cell here. So the voltage of the highest cell and the lowest cell is what this is showing. So it's now gone from 3.96 to 3.98. I measured those cells on the accurate meter and they are all 3.97 except for one of them, which is 3.96. So I need to calibrate these now. So I've done the calibration with the computer and we now have highest reading is 3.97 volts, lowest is 3.96 volts. The highest cell, the cell number with the highest voltage is number 1, and the cell number with the lowest voltage is number 3. So what this means, and what we can see when we see the computer, these are in hex values here, but anyway, you can see all of the values here are 26 except for one that's 27. That corresponds with all of them are 3.97 except for one of them, which is 3.96. Okay, so while I was doing the calibrations for this side, I also programmed this side and did the calibrations for this side as well. So that means that we can connect these together. So that means this is back to the master. That goes out of this one now. And we can go out of this one and into this one. We'll route this cable a bit better later. And now we have some faults. I'll show you what that means in a minute. And so all of the cells on that other side are 3.97, so 3.96 to 3.97. On the computer here, we've now gone from 6 cell voltages up to 12 cell voltages. Next thing to do is to plug in the temperature sensors. So on our master here, we have a temperature readout, and at the moment the highest is 0 degrees and the lowest is 0 degrees, and that's why we have the fault at the moment. Fault number 9 is low temperature. Here is the assembly for the thermometers. At the end of each of these we have a little thermistor that goes into this connector, which plugs into the circuit board. That's one of them. Other one goes up this way. And hopefully now, here we go, we have some temperatures. They're just coming up there. So the highest temperature is 21 degrees, the lowest is 19, and cell number 4 is the highest and cell number 7 is the lowest. What I like to do is I go through and check each one of these. So here, this one should be number 1. What I'll do is I'll put my finger on that and then we'll watch what it does here. So what we're looking for is the highest temperature should go up and it should become number 1. Yeah, it's just going to become number 1 anyway, just by hanging onto the wires. If I put my finger on the sensor, it quickly goes up a degree or 2. I'll just do that now for number 2. This one here is number 2. So again, I'll put my fingers on it now. 6 switches over to number 2 and goes up. So then I do that for all of these just to make sure that they're all working. It looks like they are. They're all giving us reasonable temperatures. If one of these wasn't connected, it would give us a 0. Next thing to test is the balancing resistors. This battery management system will check the voltages of all the cells, and if there's any high cell voltages, it will connect these resistors across the battery, across the cell, and that will use up some of the power, just make heat in these resistors, and it'll slowly bring the voltage of that cell down, and do that only for the high ones until they all come to the same. So that's the balancing function. We're going to test that. Because these cells are all the same voltage, it won't run any of these as we've just had it with these 12 here at the moment. So I'm going to connect up this battery module over here. So I've got another 12 cells here. And then if you look at what's going on in the master, it says our highest is 3.97. That was what the ones we just did. And the lowest is 3.49. All of the ones over here are 3.49. And the other information it's giving here is that it's balancing 12 cells at the moment. So the 12 low ones won't have their balancing resistors turned on, and the 12 high ones will. Now to test that, stick your thumb on there and make sure, see if it feels warm, or we can use a non-contact thermometer. And so a non-contact thermometer on over here where there's no resistors, 25, something like that. Over here, 40 degrees. And so we just do that to make sure that all of them have come on. So I've now neatened up this cabling somewhat. I'll just run this behind there. These are the temperature sensors, and then that communications I've run in behind there. So these temperature sensors, where I've found to put them is in between here, and I can run the cables in behind here. And the way that I do this, I just push them in, and I've got some of this stuff which is just insulation with a sticky back on it. Cut it up into small pieces, push them into there with a screwdriver. So on the one where I've done it before, there's a temperature sensor up that end. And there's another one up this end. So this is all completely flat. You don't foul on any of these temperature sensors. Up the end here you may do. And so what I've been doing is I've made this bit of acrylic here, and it just sits over top of it all. And I have more of these connectors, different size with these ones. And these just push nicely into these holes. Once you have that on, it protects this side quite nicely. It would allow less cooling through here. This would insulate it somewhat. So I'm not necessarily doing this on all of these. It just depends where they're going. If I'm using the cooling plate in the middle, then these will be fine. If I'm not, then maybe I'll leave this off. Depends on the application. What I found is that these will poke right in through under there. And then you don't need much to hold it in. That bit, that and this bit at this end. And so these temperature sensors are then sitting in right in next to the metal, and they should be quite responsive. The way that I've done it is I've had at the top here, I've got one temperature sensor on each side of this section here. The cells sit in here, and this is actually in between cells. So we've got the top of the top two cells and then the bottom of the top 2 cells. And the way it ends up is we've got the BMS has a temperature measurement for each cell. So basically there's 6 temperature measurements on here, and so I've just sort of put them around the place. 2 on the top because the top's heat rises. Maybe that's logical, not really sure. And yeah, as we go down here, we get them in different places, just distributed around the place. I put this one in the middle, and then more down the bottom, and so on. 1, 2, 3, 4, 5, 6 different temperatures. So this battery is all ready to go now. It's all assembled and tested. I've put these circuit boards on the front here so that you can sort of access everything from this end. You've got to access the terminals from this end anyway, so let's put the circuit boards on here. They could go anywhere, and I might put them on different spots depending on different projects. All the temperature leads are all in there. I haven't put the plastic things on the side. Oh, now something I do need to do is I'll remove the power from these while storing them, just so we're not using power out of the battery. That's my way of turning it off. The battery's now ready to join all the others.